designing a computational circuit in order to accomplish a given objective. The objective we have is to design a circuit that will take on an unsigned binary input from a 10-digit keypad and return a higher value if it's greater than decimal 5. As you can tell from this little board right here, we're going to be starting with the truth table. So, starting off, input 0 is going to be an output of 0, since 0 is less than 5. Input 1, less than 5, same thing. We're going to keep going for 2, 3, 4, and 5. And once we get to 6, this is the first number that is greater than 0. It is not greater than or equal to, or else 5 would also be 1. But 6 is going to be the first 1 value. And then 7 is going to be a 1 as well as 8 and 9, if the pen would work. And from here is where things get a little bit tricky. Because normally you see greater than 5, the rest of these would be filled out with 1. But since this is from a 10-digit keypad, it only goes from 0 to 9. So the rest of these are going to be don't care values, which are represented by the letter X, since these values are impossible to get from this equation. Now with the truth table filled out, we're going to fill out this Karnaugh map. So, the values here are going to be 0, 1, 1, 0 as the first one to be 1. So 0, 1, 1, 0 right here is the first 1 value. Next up is going to be 0, 1, 1, 1, which is going to be the one directly to the left of it. Then we move to 1, 0, 0, 0, which is down here. And then 1, 0, 0, 1 as the final 1. Now we want to fill in those don't care values, which are going to be 1, 0, 1, 0, 1, 0, 1, 1, and then 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and 1, 1, 1, 1. So that's going to give us that Karnaugh map. I'm going to switch pens here because we're going to group these together. Luckily, these are actually pretty easy to group. We're going to start with this group of 8 right here. Remember that don't care values are allowed to be part of the equation since we're not going to be able to get them anyway, so if it's convenient, which in this case it is, we're allowed to keep them. The next two numbers that we need are these, which are actually going to go into a group of 4 here, overlapping with, once again, the don't care values. Now, with those, we're going to break up Q into the sum of products form that we need. So, Q, we're going to start with the bottom one. Fortunately, this one is very easy. Since the only 2 values here, as well as all the don't care values, are all activated when A is 1 and nothing else affects that, Q is simply going to equal A. And then, in order to handle these, we're going to put A plus to represent OR, and this is going to be, and this one, we have B and C. And that is going to give us our equation. I've gone ahead and drawn the input and output values that we're going to be using for this logic circuit. Fortunately, this equation is simplified to something quite simplistic. So we're going to start by covering the B and C, which are going to be these 2 right here. Those are going to go into an AND gate. Quite simple. And then those are going to go into an OR gate, which is going to take either B and C or A on its own. And that, if you just connect it, is going to give you the equation, and D is not important at all. And that is going to be the final circuit in order to take an unsigned binary input from a 10-digit keypad and return a high value if it is greater than